Hello everyone, good evening. Sorry for the delay. So today we are going with class 9 polynomials, second chapter. Hi everyone. Hi Vishal. Hi Didi. Okay. So welcome to learn.cbc.in. So today our chapter is class 9 polynomials. Which is chapter 2. Okay. So already you know about the polynomial. So can anyone define the polynomial? So those who are watching the video can define the polynomial. That means can type the definition in the chat box. So, and what is a polynomial? An algebraic expression in which the powers of variables are non-negative. That means we should not non-negative integers. As not only more than 3 variables will be. Okay, not only more than 3 variables. Okay. Has it. So not only that's the algebraic expression, but we have a condition here. Listen carefully, it is an algebraic expression, that means the combination of variables and constant. But the thing is that the powers of variables must be non-zero, non-negative integers. That means we should not have negative powers, and moreover integers. I am saying about non-negative integers. That means they not be negative integers and they are not be rational also. Rational or any irrational numbers, because I am saying that non-negative integers. That means we have to take integers. In that again we have to exclude the negative integers. That means, for example, if I write one thing, x square plus y square minus 8x plus 11. Is this polynomial or not? You can type yes or no in the chat box. I am given an example here. X square plus y square minus 8x plus 11. Yes. See, here the powers are non-negative. Okay. Now, if I say 1 by x square plus x cube plus 11. Take this example. 1 by x square plus x cube plus 11. Is this polynomial or not? Mention whether it is polynomial or not. No, why? Why Sylvie, why it is not a polynomial? See why it is not a polynomial. See, if I write this x power minus 2 plus x cube plus 11. If you observe carefully, here the power we have negative integer. We should not have negative integer. I already told you. We should not have negative integer. So it is not a polynomial. Not only this. If you take x power 3 by 2 plus 11, this is also not a polynomial because the power should not be rational. power should not be rational. Okay. So the condition is that polynomial is an algebraic expression, but the condition is that power of the variables must be non-negative integers. Must be non-negative integers. Okay. Next, degree of a polynomial. So what is degree of particular polynomial? How can you define the degree of a polynomial? Can anyone see? Those who are watching can type in the chat box. What is the degree of the polynomial in short form? No need to give full definition, just give in short form. What is the degree of the polynomial? Really, number of terms different, not number of terms. Tell me which power? You have just mentioned power. Which power? The highest power of a given polynomial, the highest power of a given polynomial is nothing but is the degree of given polynomial. Is the degree of the polynomial. So we have to get the highest power of the given polynomial. That is said to be degree of the polynomial. Okay. Now see once. What is the degree of the given polynomial? What is the degree of the given polynomial? Three. See once, here power is 1, 2, 3. Highest power is 3. Now say what is the degree of the polynomial? Here degree equals to 3. Now say what is the degree of the given polynomial? What is the degree of the given polynomial here? Riddhi, 5 is the not correct answer. Check properly. It's not 5. Check it properly. Observe carefully. So while writing the power of the term, see here only we have one variable 5, one variable x power 5. So power here is 5. Here 2. Here we have to add the individual powers of different variables. So 3 plus 4, 7. Now power of this term is 7. The power of this term is 7. Okay. Okay. Okay, so we have to add these two. That means we have to get the degree of individual terms. So 4 plus 3 will get 7. So obviously the degree is 7. The degree is 7. Okay. Now what is the coefficient of the term, particular term? Coefficient of a term. What is the coefficient of a term? So the constant which is taken as product of variable is said to be coefficient of particular term. For example, if I am taking an example here, 4x cube plus 5x square plus 7x plus 11. Okay, if I ask the coefficient of x cube, what is the coefficient of x cube here? Coefficient of x cube. Coefficient of x cube. Yes, 4. Coefficient of x cube is 4. What is the coefficient of x? Coefficient of x. What is the coefficient of x? It is nothing but 7. Coefficient of x square, S to the SLV, and coefficient of x square 5. So everyone those who are watching can type the answers in the chat box. Okay. Now see, based on degree of the polynomials are classified as, see, first of all, if I take degree 1, degree equals to 1, what is the name of the polynomial? If I take degree equal to 1, what is the name of the polynomial? So those who are watching the video can type in the chat box. If degree equal to 1, what is the name of the polynomial? Linear polynomial. This linear, not monomial, Sylvie. That is based on terms. If degree equals to 1, it is linear polynomial. If degree equals to 2, what is the name of particular polynomial? If degree equals to 2, what is the name of particular polynomial? See once. If degree equal to 2, it is quadratic polynomial. So those who are watching video can type the answer in the chat box. Now, if degree equals to 3, it is cubic polynomial. And if degree equals to 4, it is biquadratic polynomial. It is biquadratic polynomial. Can anyone say example for linear polynomial? I am saying that if the degree of the polynomial is 1, it is said to be linear polynomial. Now, can you say example for the linear polynomial? Sylvie, yes. X minus 7, yes. If we observe this, the degree of this term is 1. So obviously it is one of the example for linear polynomial. 3x, yes. Even 3x also ready. Because the degree is 1, it is also linear polynomial. Now, give the examples for quadratic polynomial. That means, if the degree equals to 2 of particular polynomial, it is said to be quadratic polynomial. X power 2 plus 7, SLV. X power 2 plus 7. Any other answer? 4x power 2, yes, ready? 4x power 2. Yes. Now, give the example for cubic polynomial. Give the example. That means you have to get the degree as 3 for particular polynomial. As 5x power 3 plus 8 x plus y power 3. Yes, Riddhi, it is also correct. Now biquadratic polynomial. That means degree 4. If the polynomial has degree 4, it is said to be biquadratic polynomial. So give example for biquadratic polynomial. So the polynomial should have the degree 4. You can type in the charter box. 6x power 4, 6x power 4 plus 67. Very good, Selvi, correct one. Okay. Now see, if we have more than 4 as degree for any particular polynomial, generally it is said to be polynomial. Okay. Now can we have more than one variable for linear polynomial? Say yes or not. Can we have more than one variable for linear polynomial? I'm asking that. Linear polynomials you should have degree 1. Can we have more than one variable for linear polynomial? Yes. Say one example. Yes, we may have variables more than one. That means you can take 2 variables, 3 variables, 5 variables, but the degree should be 1. We can take many number of variables, but that s with the x plus y, Shall we check once? X plus 3x, it is only one variable. Again you will get 4x on solving that. Okay, so x plus y, x plus 3y. Even you can take number of variables, x plus 3y plus 4z plus 8w. That means here we are not worrying about the terms and variables. If the particular polynomial having the degree 1, regardless of the number of variables in that polynomial, it is said to be linear polynomial. We may have many number of variables, don't worry about the variables. Okay, don't worry about the terms. Only we should worry about the degree, highest power. So in these 3 examples we have highest power as 1, that means the degree 1. So all these are the examples for linear polynomial. Remember, not similar for quadratic and cubic, so on for biquadratic. We may have many number of variables, but that we have to satisfy the degrees to say whether it is quadratic or cubic or biquadratic. Okay, is it clear? So everyone is clear with this classification of polynomials? Type yes or no. Everyone is yes. Okay, okay, Selvi. And we have 2 more classifications here. Those are constant polynomial. Can you say degree for the constant polynomial? Can you say what is the degree for the constant polynomial? Anyone? Okay, Riddhi. Can you mention the degree for the constant polynomial? So those who are watching the video, they can type in the charter box. I am asking the degree for the constant polynomial. Not 1, Riddhi. 0. If the degree is 1, it is said to be linear polynomial. If the degree is 0, it is said to be constant polynomial. So in constant polynomials, generally we take constants itself. 8, 100, 234. Only 8 is said to be constant polynomial. Only 100 is said to be constant polynomial. So if you take any numerical value, it is said to be constant polynomial. See how we define the degree as 0. I can write 8 into x power 0. 8 into x power 0, because 8 into x power 0, that means x power 0 means 1, again you will get 8 itself, that means 8 can be written as x power 0. So the highest power is 0, so the degree equals to 0. Now I am asking that, can we have more than one term in the constant polynomial? So before, for linear and quadratic, we may have many number of terms regardless of the degree. That means if the degree should be satisfied for whether it is cubic, quadratic or linear, we may have many number of terms. Now I am asking that in constant polynomials we may have more than one term. So we are saying yes, no. See once, if we take 8 plus 6, it is not two terms, both are like terms, you can add them and make it single term. If you take any variable here, 8x plus 6, it is not a constant polynomial. That means if it is said to be constant polynomial, we should have only single term, that is nothing but the constants, that means nothing but the numerical values. Okay, that's really good. Now go with the zero polynomial. So which one is said to be the zero polynomial? Which one is said to be the zero polynomial? So only 0 is said to be the zero polynomial. Only 0 is said to be the zero polynomial, and the degree of zero polynomial is, can anyone type there? Degree of zero polynomial. I am asking the degree of the zero polynomial. Not 0, it is undefined. It is undefined. See, I will explain why it is undefined. See, I can write 0 as 0 into x power 8, 0 into y power 4. So anything results in the 0, because 0 into anything will give 0. It may be 8, it may be 4, it may be 7, it may be 6. So we cannot say exact value of degree for the zero polynomial. So the degree of the zero polynomial is undefined. So the degree of zero polynomial is undefined. Okay. Now we can move based on terms, based on number of terms. Polynomials are classified as number of terms. If you have one term, the polynomial is said to be, can anyone answer? If you have one term in the polynomial, given polynomial, it is said to be, so those who are watching can type the answer in the chat box. As Riddhi and Selvi, very good. It is monomial. It is monomial. If the polynomial has two terms, which type of polynomial it is? Mention the name of the polynomial having two terms. Having two terms. As Selvi, it is binomial. Binomial. If the polynomial having three terms, what is the name of the polynomial? SL, it is trinomial. Trinomial. As with the before it is binomial. Now, if the polynomial having four terms or more, it is said to be the polynomial having 4 or more terms. No, it is said to be, generally it is said to be multinomial. Multinomial. That means if the polynomial having only single term, it is said to be monomial. If the polynomial having two terms, it is said to be binomial. If the polynomial having 3 terms, it is said to be trinomial. If the polynomial having 4 or more terms, it is said to be multinomial. So can anyone say the example for monomial? Example for monomial. You can type in the chat box. Just I am asking the example for monomial. Those who know can type in the chat box. X is x, y, 5y, even c, x cube, 4y, y 5. All these are monomials only with single term. Now get the example for binomial. S with the y power 2. Get the example for binomial. S Shivam, x plus 2. S x plus 2. Sylvie, x plus 3, correct answer. So if you are having 2 terms, it is said to be binomial. Okay. Shivam, x plus y. Okay. Now get the example for trinomial. Get the example for trinomial. S Shivam, x plus y plus z. S x plus 7y minus 6. Yes. Okay. Now multinomial means you have more than 4 terms. If you have more than 4 terms, it is said to be multinomial. Now I am asking that in monomial, can you have more than one variable? If you take monomial, can we have more than one variable? Yes or no? For taking monomial, can we have more than one variable? No, yes, because we should have only one term. If you take 2 variables, obviously it is leading to the binomial, 2 terms. So observe carefully. Can I write xy? Is it monomial or binomial? Oh, already this is given xy. Okay, see once. Shivam, see once. If I write xy, is it monomial or binomial? Yes, monomial. See, because this is single term. It is single term. Even I can write xyz also. Okay, xyz also. So all these are monomials. That means we can write more than one variable in monomial. More than one variable in monomial. Okay, don't confuse here. And we can take as much as degree. You can take degree 8, degree 5 in even in monomial or binomial. See, even in binomial, see, I can write x power 10 plus y power 12. Here we are not bothering about the degree. See, what is the degree of this binomial? 12. Degree of this binomial is 12. Okay. So we may have any degree for monomial or binomial, trinomial. Here only we are depending upon the terms. So we can start exercise 2.1. Exercise 2.1. So which of the following expressions are polynomials in one variable and which are not? He is asking that in given sums which are the polynomials in one variable and which are not. See, first one, 4x square minus 3x plus 7. 4x square minus 3x plus 7. Is it polynomial in one variable or not? Yes. Only the variable is x. Yes. We have only one variable, that is nothing but x. Next sum. y square plus root 2, y square plus root 2, as only variable is y. So see third one, 3 root t plus t root 2. The second one is this. Go for third one, 3 root 2 plus t root 2. Yes, Riddhi, you are correct, and Selvi also correct. It is not a polynomial itself, because see, if you take this one, it is t power 1 by 2. I already said the power of any variable in the polynomial must be non-negative integer. Here we got the rational number. Okay, so it is not a polynomial. It is not at all. It's not a polynomial. And go for the t, y plus 2 by y, y plus 2 by y. Is it the polynomial in one variable? No, it is also not a polynomial, because see, if you modify this, y plus 2 into y power minus 1, 1 by y can be written as y inverse. So we got here negative integer. Obviously it is also not a polynomial, not a polynomial. Okay, now second main, exercise 2.1, second main, first question. Exercise 2.1, second main, first question, and is asking that write the coefficients of x square in each of the following sums. So first one, here we have to mention the coefficient of x square. 2 plus x square plus x. What is the coefficient of x square here? What is the coefficient of x square? First main question 5 is here. Okay, see once. What is the coefficient of x square? S1, SLV, Riddhi given one SC. Coefficient of x square is 1. Here coefficient of x square equals to 1. Now see second one, 2 minus x square plus x cube. So what is the coefficient here? What is the coefficient here? Yes, it is minus 1, because minus x square is nothing but minus 1 into x square. So the coefficient of x square in second sum is minus 1. Here the coefficient of x square is nothing but minus 1. Pi by 2 x square plus x. Pi by 2 x square plus x. Pi by 2 x square plus x. Now I need again the coefficient of x square here. As Riddhi, it is pi by 2. Coefficient of x square equals to pi by 2. Pi by 2. S Selvi, it is pi by 2. S Shivam. Last one, root 2 into x minus 1. What is the coefficient of x square in this polynomial? The polynomial is root 2 into x minus 1. Now I am asking the coefficient of x square here. Yes, Selvi 0, because there is no x square term. So obviously coefficient of x square equals to 0, because there is absence of x square term. There is absence of x square term. So the coefficient is 0, because I can write this as plus 0 into x square. Is there any modification for the given polynomial? No, because we are adding just 0. 0 into x square is nothing but 0. So obviously the coefficient of x square is 0. Okay. Now see the third sum. Give one example each of a binomial of degree 35 and a monomial of degree 100. First of all, we have to give the binomial with degree 35. That means the polynomial should have degree 35 and it should be a binomial. It should be a binomial. Exercise 2.1 third sum it is. Exercise 2.1 third sum is asking that give an example for binomial which having degree 35. As with it 2x power 35 plus 6y, okay, 2x power 35 plus y. Yes, this is binomial because it has two terms. It is binomial and it has two terms, and moreover the highest power is 35, so it having degree 35. Now I need monomial with degree 100. I need monomial with degree 100. Yes, y power 100. You can take anything, y power 100 or x power 50 into y power 50. So it is monomial and degree is 100. 50 plus 50, 100. Okay. Now we have to find the degree of each of the following. So chapter 2 to exercise 2.1 third sum, fourth sum, we have to find the degree of each of the given polynomials. The first one is, the fourth one, the first one is 5x cube plus 4x square plus 7x. I need degree of this polynomial. As Shivam, 3, Riddhi 3, yes. See, highest power is 3 here, 2, 1, 3. So the degree of the given polynomial is 3. Now second one is same main, 4 minus y square. 4 minus y square. S2, highest power is 2 here. So degree of given polynomial is 2. Degree of given polynomial is 2. Third one, 5t minus root 7. What is degree in this sum? What is the degree of given polynomial here? 1. Yes. See, t is a variable here. T is a variable here. We have 1. This is the highest power. So obviously degree equals to 1. Then what is the degree of the 3? Polynomial 3. What is the degree of polynomial 3? Yes, 0. Because this is the constant polynomial. I already said that degree of constant polynomial is 0. Okay. So you can go through learncbse.in for the solutions of each and every chapter and each and every subject also. Now next main, exercise 2.1 polynomials. Fifth main is asking here, classify the polynomials as linear, quadratic and cubic polynomials. First one, fifth main, first one, exercise 2.1, x squared plus x. Here we have to mention whether they are linear or quadratic or cubic. So first one, yes, it is quadratic. Yes, it is quadratic. Because the degree is 2, it is quadratic. Hi Deepali. Next, go for the second one. Go for the second one. X minus x cube. X minus x cube. Is it linear or quadratic or cubic? Yes, Shivam and Riddhi, yes, you are correct. It is cubic polynomial. It is cubic polynomial. Go for the next one. Y plus y square plus 4. Y plus y square plus 4. Y plus y square plus 4. As to it is quadratic. It is quadratic. Because the highest power is 2, nothing but the degree is 2. It is quadratic polynomial. Next one, 1 plus x. 1 plus x. Which type of polynomial it is? 1 plus x, linear, quadratic or cubic? As it is linear. It is linear. As Shivam, it is linear. Now 3t. 3t. 3 into t. Is it linear, quadratic or cubic? Yes, it is also linear polynomial because we have only degree 1. Highest power is 1. Next one, r square. R square. Next one is r square. As it is quadratic. It is quadratic because the degree is 2 here. Last sum in fifth main, 7x square. 7x square. Yes, quadratic. All have to given correct answer. It is quadratic. It is quadratic. So with this we finish the problems in the exercise 2.1. Okay. Now we can move with 0 of the polynomial. 0 of the polynomial. What is said to be 0 of the polynomial? Can anyone define? You can type in the chat box. What is the 0 of a polynomial? What is said to be 0 of a polynomial? See once. The value of a variable, the value of variable at which given polynomial becomes 0. That means if you are given on polynomial, if you substitute the value of variable as any number, then if the given polynomial becomes 0, then it is the value of the variable is said to be the 0 of the polynomial. For example, if I take one polynomial 5x minus 5, 5x minus 5. See here, x is the variable. I can choose x equals to minus 1, x equals to 2, x equals to 1, x equal to 5 because x is the variable. I can have any number of values, for x. I can choose any value for the x. Okay, I can choose any value for the x. So for what value of x the entire polynomial becomes 0? At what value of x the entire polynomial becomes 0? That value of x is said to be the 0 of the polynomial 5x minus 5. Okay, see once, if I place minus 1, that means let the given polynomial p of x equals to, let given polynomial p of x equals to 5x minus 5. Yes, Now I am taking x as minus 1. That means p of minus 1. At x equal to minus 1, it means that I am substituting minus 1 wherever I see the x. So p of minus 1 equals to 5 into minus 1 minus 5. That means 5 into minus 1 you will get minus 5 minus 5. The answer is minus 10. Now I am taking x equal to 2. That means at x equal to 2, it means that p of 2, wherever you see the x, you are substituting with 2. P of 2 equals to 5 into 2 minus 5. 5 to 10 minus 5. 10 minus 5 you will get 5. Now again x equal to 1. At x equals to 1, that means in the place of x you are replacing with 1. So p of 1 equals to, wherever you see x you have to replace with 1. 5 into 1 minus 5. 5 minus 5, 0. Now I am substituting x equal to 5. That means at x equals to 5, it means p of 5, wherever I see x I substitute with 5. So 5 into 5 minus 5. 5 5s 25 minus 5. The answer is 20. In all these 4 cases, where you got 0? Among these 4 cases, where you got 0? In the third case. As with the 0 is 1 itself. That means, see in this case, when you replace the value of x with 1, the answer of the polynomial is, after solving with placing x equal to 1, you got 0. Then x equal to 1 is 0 of the polynomial 5x minus 5. Simple thing is that if you replace the variable with any value, the entire polynomial become 0. That value is said to be the 0 of the polynomial. Okay. Any doubt here? As Shivam, x equal to 1. Any doubt in the concept of 0 of the polynomial? You can type in the chat box. Any doubt here? Okay. Now we can move with the chapter 2, exercise 2.2. Okay, Shivam. Exercise 2.2. Okay, ready? Very good. So, exercise 2.2, chapter 2. First main, find the value of the polynomial. He given one polynomial 5x minus 4x square plus 3. He given one polynomial and is asking the value of the polynomial first at x equal to 0. At x equals to 0. Okay. So exercise 2.2, first sum. He given one polynomial 5x minus 4x square plus 3. He is asking the value of the polynomial at x equals to 0. Get the answer for this? Let's take it as p of x because this is in the polynomial x. 5x minus 4x square plus 3. Now I am asking at x equal to 0 what is the value of the polynomial? What is the value of the polynomial at x equals to 0? As with the Shivam, it is 3. That means just replace 0 in the x, you will get 0 minus 0 plus 3. Obviously 3 is the answer. Now second one, at x equals to minus 1, at x equals to minus 1, that means replace x with minus 1 and get the answer. Replace x with minus 1, get the answer. S with 3 is correct before S. Now substitute with -1. Check Shivam once again your answer. Do properly. You have to place x equal to -1 in the given polynomial and you have to find the value of particular polynomial. S -6 is the correct answer. See once, in the place of x you have to replace with -1. Then you will get 5 into -1 minus of 4 into -1 whole square plus 3. 5 into -1 you will get -5. See, -1 whole square, obviously you will get 1. So 4 into 1, 4, minus is here, so -4. Because square of any negative number is positive. Okay. Plus 3, you will get -9 plus 3, obviously -6 is the answer. -6 is the answer. This is correct. -6. Now we can move for the next sum. We can move for the next C bit x equal to 2. Now we have to find the value of polynomial at x equals to 2. At x equals to 2. So replace the value of x with 2 and get the answer. That means you have to get P of 2. Shivam, check the answer once. Check the sign. Check the sign. Just replace x with 2. That means substitute the value of x as 2 and get the answer. S with e, it is -3. Shivam, check the answer once. So 5 into 2 minus 4 into 2 whole square plus 3. 10 minus 2 square 4. 4 4s are 16 plus 3. 10 plus 3 13 minus 16. Obviously you will get -3 as the answer. Okay. Next. So exercise 2.2, second chapter polynomials, exercise 2.2, second one, second main. Now he is asking to find P of 0, comma P of 1, P of 2. He is asking to find P of 0, P of 1, P of 2 for given polynomials. So first polynomial I am taking P of y equals to y square minus y plus 1. So for this particular polynomial you have to find P of 0, P of 1, P of 2. All these three we have to find for given polynomial. Okay, P of 0 1, Shivam, it is correct. Go for next one. C, substitute 0 in the y. P of 0 equals to 0 0, you left with only 1. Now find P of 1. Find P of 1. For same question, find P of 1. Check Sylvie once. I am asking for P of 1. S with it is 1. S, because 1 square 1 itself, 1 plus 1 plus 1 and minus 1 get cancelled, you left with 1. Now P of 2, substitute the value of 2 in y in the given polynomial, you will get the answer. Okay Shivam, 1 1 3 is correct answer. So third one you will get 3. See once, place 2 in the y, 2 square minus 2 plus 1, that means 4 minus 2 plus 1, 4 plus 1 5, 5 minus 2, obviously you will get 3. Okay. Now we can move for the second sum. in same main exercise 2.2 second main second sum, P of t equals to 2 plus t plus 2t square minus t cube. P of t equals to 2 plus t plus 2t square minus t cube. Again for this sum we have to find P of 0 and P of 1, P of 2. Shivam, you are given 2, 4, 4. So 2 is the correct answer. The first one, Selvi and Shivam. Yes, ready? See once. All these terms becomes 0. So only you left with 2 because 0, 2 into 0 minus 0. So all these 3 terms become 0, you left with only 2. Now go with P of minus 1, P of minus 1, sorry, P of 1. That means substitute the value of t as 1, you will get the answer. Already Shivam is given the answer. It is correct. 4. Hi Sujit. No, it is not 3. Check once carefully. See, if you substitute 1 in the place of t, 2 plus 1 plus 2 into 1 whole square minus 1 cube. That is nothing but 2 plus 1 plus 1 square means 1. 2 ones are 2 minus 1 cube minus 1 plus 1 minus 1 cancel. 2 plus 2, you will get answer as 4. Okay, not 3. Not Selvi, it is not 6. Already Shivam given answer 4. Yes, yes Riddhi, you also given answer 4. Very good. As Sujit, it is 4. Now we have to go for P of 2. That means in the place of t we have to substitute 2. The place of t we have to substitute 2. So in the place of t we have to substitute with 2. Get the answer? Wherever we see the t, you have to substitute with 2. Already answers are given. Riddhi, Sujit are given 4. Already Shivam given previous itself 4. Not Selvi 10, it is not 10. 4 is the answer. Check once. 2 plus, in the place of t we will get 2 plus 2 into t square. Obviously 2 square minus t cube. That means 2 cube. Now 2 plus 2 4 plus 2 square 4. 4 2's are 8 minus 2 cube 8 plus 8 minus are get cancelled. You left with 4. The answers are 2, 4, 4. Okay. Yes. Now we can go for the third sum in second main. Now we are solving the exercise 2.2 chapter 2 polynomials. Second main third sum. Second main third sum. P of x equals to x cube. It is very easy to answer. Only single term is here. It is monomial. We can say directly answers P of 0, P of 1 and P of 2. 018. Yes, Shivam. 018. Remaining people also type the answer. Yes, Riddhi. Yes, 018 because it is a monomial. Directly you can say answer by observing this. P of 0 that means 0 cube. Obviously 0. P of 1 that means 1 cube. In the place of x we are keeping 1. Now in the place of x we are replacing with 2 cube. Obviously it is 8. So 0, 1, 8 is the 8 are the answers. Very good. So those who are watching can type the answers in the chat box. Now polynomials chapter exercise 2.2 second main fourth sum. P of x equals to x minus 1 into x plus 1. X minus 1 into x plus 1. This is the polynomial chapter exercise 2.2, second main fourth sum. So those who are watching the live video, you can share with your best friends and even they can get the benefit as you are getting. And hit the like button those who are watching the video and encourage us. Now P of 0. Shivam already given answers. Okay. Hi Raghav. Oh yes, Raghav. You are saying that you are just basics. 2 into 1 equal 2. Okay. So P of 0, 0 minus 1 into 0 plus 1. So obviously minus 1 into plus 1. You left with minus 1. Already they also given us very good correct answer. Now P of 1. P of 1. In the place of x we are replacing with 1. So 1 minus 1 into 1 plus 1. 0 into 2. Obviously it is 0. P of 2. P of 2. That means replace with 2. 2 minus 1 into 2 plus 1. 2 minus 1 is 1. 2 plus 1 is 3. 1 into 3 results in 3. So the answers are minus 1, 0, 3. Minus 1, 0, 3. Very good. So given answers as early as possible. Okay, we can move for next main. So we are dealing here polynomials, exercise 2.2. Third main, polynomials, exercise 2.2, second chapter, third main is asking now, verify whether the following are zeros of the polynomial indicated against them. Verify whether the following are zeros of the polynomial indicated against them. That means he given the polynomial as well as he given the zero of the polynomial. We have to check whether the given answer is the 0 or not. See once, first polynomial P of x equals to 3x plus 1 and 0 is given as x equals to minus 1 by 3. Minus 1 by 3. Yes, even first one is correct. Yes. See, how will you verify that? First of all, take the polynomial and find the 0 yourself and check with the given 0. If it is matching, the answer is correct. So when you are asking to find the 0, make it the given polynomial equals to 0. So 3x, if you transpose plus 1 to right side, you will get minus 1. Again, if you transpose to 3, you will get by 3. So minus 1 upon 3. So this is the 0 of the given polynomial. Already he also given x equals to minus. Yes. Now go for the second one. P of x equals to 5x minus pi and 0 is given as x equals to 4 by 5. Now see, is this the value x equal to 4 by 5 is the 0 of the given polynomial 5x minus pi or not? Say yes or no. Already Shivam given answer no. So remaining people who are watching this video can also answer, and those who are watching can hit the like button to encourage us, and you also can inform your friends, your best friends to watch the video. Now find the 0 of this polynomial. That means whenever we need to find the 0 of the polynomial, make it equate to 0. So 5x minus pi equal to 0. If you transpose minus pi, thank you Raghav, thank you for your great feedback. So 5x equals to transpose minus pi to right side, you will get plus pi, and transpose 5 to right side, you will get x equals to pi by 5. So now actually the 0 of the given polynomial is pi by 5, but he given 4 by 5. Therefore it is not a 0. He does not given a correct answer. Here he given 0. Here he not given the 0 because 0 is pi by 5. He given 4 by 5. Okay. Yes, Vidhi? No is the correct answer. Now we can move for the third sum in exercise 2.2 polynomials. Okay. Now p of x equals to, see the given polynomial, p of x equals to x square minus 1 and given zeros as x equals to 1 minus 1. Observe carefully, in previous two sums he given only 1 0. In this sum he given 2 zeros because first and two sums are linear polynomials and third one is quadratic. And remember one thing, number of zeros the given polynomial is equals to the degree of the polynomial. So whatever the degree of the polynomial, those many number of zeros are for given polynomial are there. Okay. Shivam S, correct answer. C ones, I already told we have to equate with 0 to get the zeros. X square minus 1 equal to 0. Observe carefully, it is in the form of a square minus b square. I can write 1 as 1 square. So x square minus 1 square equals to 0. It is in the form of a square minus b square. So a plus b into a minus b. Yes, Vidhi? That means x plus 1, a plus b. Here a equal to x, b equals to 1. A plus b into a minus b equals to 0. That means, observe carefully, whenever the product becomes 0, either one of these terms should be 0. That means x plus 1 equal to 0 or x minus 1 equal to 0. Yes or not? If this term becomes 0, 0 into something 0. If this term becomes 0, 0 into something 0. Either one of the term must be equals to 0. So here x equals to minus 1, you will get here x equals to plus 1. So plus 1 and minus 1 are the zeros of the given polynomial. Already he given correct thing. Okay. Now fourth sum in the third main, same exercise 2.2. The polynomial is p of x equals to x plus 1 into x minus 2 and the zeros are given by x equals to minus 1 comma 2. X equals to minus 1 comma 2. Say whether yes or not. Minus 1 and 2 are zeros of given polynomial or not. I already told what is a 0? 0 means here the polynomial is in terms of x. Whenever you replace the value of x with any numerical value, the entire polynomial should become 0. That is the 0 of the polynomial. Now he given minus 1 and 2 as zeros of the polynomial. Check whether they are zeros of the polynomial or not. Yes, Shivam is given as yes. Check once. First of all, we have to equate with 0. Given polynomial equate to 0. That means either x plus 1 equal to 0 or x minus 2 equal to 0. Solving this, you will get x equals to minus 1. Solving this, you will get x equals to plus 2. So minus 1 plus 2. Yes, these are the zeros of the polynomial. So we can move with next one, fifth sum in the same main. P of x equals to x square and x equals to 0. That means this is the given polynomial. He given as x equal to 0 as the 0 of the polynomial. Is it yes or not? See the answer is 0 of the given polynomial x square. Type whether it is yes or not. So x square equals to 0. Obviously x equals to 0. So 0 is 0 of the given polynomial s. It is given s. Now next one, the polynomial is given as p of x equals to lx plus m, where x equals to minus m by l, where x equals to minus m by l. See this last one, sixth one, he given polynomial as p of x equals to lx plus m, and 0 as given x equals to minus m by l, Yes, it is. Check once. Equate the given polynomial to 0. Lx plus m equals to 0. That means transpose m to right side, you will get minus m, and x equals to minus m by l. He also given the same one. So this is the 0 of the given polynomial. So seventh one, in same main, p of x equals to 3x square minus 1, and the zeros are given by x equals to minus 1 by root 3 comma 2 by root 3, minus 1 by root 3 comma 2 by root 3. Now answer this question. He given the polynomial 3x square minus 1, and the zeros are x equal to minus 1 by root 3 and 2 by root 3. Are the given are zeros for the given polynomial or not? Really check once properly. Check once properly. C1. First of all, equate the given polynomial to 0. On transposing minus 1 to right side, you will get 3x square equals to 1. 3x square equals to 1. Transpose 3 to right side, you will get x square equals to 1 by 3. X square equals to 1 by 3. So transpose square to right side becomes root x equals to square plus or minus square root of 1 by 3. X equal to plus or minus square root of 1 by 3. That means x equals to plus 1 by root 3, and also x equals to minus 1 by root 3. He given one as correct, another one is wrong. Okay, 1 by root 3 and minus 1 by root 3. Yes, Shivam, it is correct? No. Only 1 0 is correct, other 0 is wrong here. So 1 by root 3 minus 1 by root 3 are the zeros of the polynomial. So eighth sum in exercise 2.2. Third main eighth sum, p of x equals to 2x plus 1, and 0 is given by x equals to 1 by 2. X equals to 1 by 2. See this one. Polynomial is given by 2x plus 1 and x equals to 1 by 2. Now, is it 0 of the given polynomial or not? Is it 0 of given polynomial or not? Riddhi, not yes. Riddhi is correct. Shall we check once? If you equate 2x plus 1 to 0, equate 2x plus 1 to 0, transpose plus 1 to right side, you will get 2x equals to minus 1. 2x equals to minus 1. And again if you transpose 2 to right side, you will get x equals to minus 1 by 2. Actually 0 of the given polynomial is minus 1 by 2, but he given as 1 by 2. And remember the standard form for linear polynomial. If the linear polynomial is in the form of ax plus b, then the 0 is given by x equals to minus b by a. X equals to minus b by a. This is the standard form of the 0 for given linear polynomial. Ax plus b is the linear polynomial, then x equals to minus b by a is 0 for the given polynomial. Okay. Check once. So with this completed this main. So this is how we can find the zeros. Whenever he asks to find the 0, first of all equate the given polynomial to 0, then you will get the zeros. So exercise 2.2 polynomials, and moreover one thing, you will get the answers for each and every subject in learncbse.in website. So if you type this and any subject, you will get the solutions for every subject. Okay, you can type learncbse.in. Now the fourth question in same exercise, find the 0 of the polynomial in each of the following cases. Fourth main, first one, exercise 2.2 polynomials. First sum. Now here he is asking, you have to find the 0. Before we have find the 0 and we have check with whatever given. Now it is enough to find the 0. First question, p of x equals to x plus 5. P of x equals to x plus 5. So someone is given directly answers. Take. What is your name? Critic. Selvi, not 5. Shivam, it is correct. Minus 5. First one is minus 5. C, equate it 0. X plus 5 equals to 0. X plus 5 equal to 0. Then you will get x equals to minus 5. I already told, whenever it is in the standard form, that means in the linear, it is in linear polynomial, C, constant term. You have to write, if it is plus means you have to write minus b by a. So for plus 5 you will have minus 5 divided by 1. Obviously it is minus 5. On seeing them you can directly get the answers. If you observe this, if you get this, directly you can say the answer without equating 0. Second one, p of x equals to x minus 5. P of x equal to x minus, Shivam already given. But see once, first one is minus 5, second one is plus 5. Shivam, check properly. Okay, Selvi? Yes. First one is minus 5, second one is plus 5. Now see, equate x minus 5 to 0. You will get x equals to 5. X equals to 5. Okay. Now third one, in same main, he given p of x equals to 2x plus 5. So compare with this, directly you can say answer ax plus b minus b by a is the answer. So b is 5, minus 5 by 2 is the 0. Okay, 0 of polynomial. Directly you can say for the linear polynomials, directly we can say by comparing this. Okay, minus b by a. So minus 5 upon 2. Yes, really? Yes, second one is 5, correct answer. Okay. We can move to next one. P of x equals to 3x minus 2. P of x equals to 3x minus 2. What is the answer? What is the answer for this? 2 by 3 is correct answer, Shivam. So, Riddhi, Selvi, Shivam, Raghav, Sujit, Vishal Sharma, you are following the class continuously. So, please inform your best friends for the next session. So, those who are watching now, you can also inform to your best friends and they will also get benefit from this. Next time, come along with your friends and have a great session with your friends. Okay, now see, P of x equals to 3x minus 2. Already said minus b by a. So, minus into minus plus 2 by 3. A equal to 3 here. Answer is 2 by 3. Very good, Selvi. So, go for next one. P of x equals to 3x. P of x equal to 3x. What is the 0 for this? What is the 0 for this? 3x. Yes, 0 itself. Whenever a given monomial with variable, obviously the 0 of polynomial is nothing but 0 itself. If a given monomial, remember the thing, not only 3x, 3x cube, 5x, 4x power 5. If you given the variable with monomial, obviously the 0 will be 0. Blindly we can go with that. Okay. Sixth one, P of x equals to ax, P of x equals to ax, and a is not equal to 0, where a is not equal to 0. What is 0 for this? Yes, again yes, again it is 0. Shall we not x? 0, 0 is the answer. At x equal to 0, you will get the entire value of polynomial as 0. Again, the 0 is here also, in this case also 0 itself. Last question. P of x equals to cx plus d, where c not equals to 0 and c and d are real numbers. Where c not equal to 0, c and d are real numbers. See, already I said it is in the form of ax plus b, but here he given cx plus d. Directly you can answer this. If you observe the ax plus b, you can directly answer this. Yes, 0 is nothing but minus d by c. In the place of b given d, in the place of a given c, so minus d by c. Very good, Shivam, minus d by c. So Friday we will have the exercise 2.3 polynomials. That means, see, we are going with division of polynomials. Next session will be on Friday, this Friday. We are going with remainder theorem, factor theorem, and division of polynomials. Next session will be on this Friday, and these are very important topics for this chapter: remainder theorem, factor theorem, and division of polynomials. So once again I am saying, see, Riddhi, Selvi, Shivam, Raghav, Sujit, Vishal and Kritik, you can also bring your friends. Next Friday we are going with these three topics, and these are very important for this chapter. So and finding the zeros, already we are done with zeros of the polynomial and values of polynomial at particular values of variable. Okay, and types of polynomials, already we have done with these three things mainly today's session, and these are very easy and these are very basic for the polynomials. Next Friday we are going with remainder theorem, factor theorem, division of polynomials, which are being complicated in this chapter. So inform your friends. So next Friday come along with your best friends, and it is very easy for them to understand these topics. Okay, Hi Shubham Bhadraj. Thank you Shivam for a great feedback. So if you have any doubts in this today's topic, you can ask now. If you have any doubts about the degrees, about the coefficients, if you ask that is it possible, it is not possible, I will say the answer. Thank you Sylvie, thank you Rudy. If you have any questions, you can ask now. I will clear. Yes Rudy. So those who are watching the video can hit the like button, and those who are new viewers, you can subscribe our channel to encourage us. So next Friday it is very important topic in this chapter, remainder theorem, factor theorem and division of polynomials. Don't miss the class, and even bring your friends along with you, it is helpful for them. And follow the lanecbse.in website, you will get the solution for all chapters, not only for maths, all subject also, for each every class. Okay, see the question of Reddy. If a variable have degree 4, which type of polynomial it will? So you are having a, for example, think a power 4. So the degree is 4. So obviously that if degree is 4, for example, you are given like this question. Okay, that means degree of the polynomial is 4 here. It is said to be biquadratic. It is said to be biquadratic. What is with x power 4? Yes, same thing. See, x power 4, for example, I am taking 3x power 4, 4x cube plus 5x square plus 11. So what is the degree of this polynomial really? Obviously 4. 4 is the degree of the polynomial. So this is called as biquadratic polynomial. If the degree of the given polynomial is 4, it is said to be biquadratic polynomial. Are you getting ready? What you have asked? Okay, thank you. Anyone else doubts? You can raise your questions in the, you can type in the chat box. We will wait for your questions. And remember that this is the one of the important topic. ठीक है रिधि? And remember one thing, polynomial is very important chapter, not only for this class, upcoming classes, 10th, 11th, 12th also. It's very basic. You can raise any doubts if you have. Those who are watching the video, you can raise the doubts on today's session. Polynomials. Okay, Riddhi? Anyone else? If you have any doubt, Selvi, Shivam, Raghu, you have already watched the video, still you are watching. You can ask any doubt we have. Okay, this is the end of the session. So thank you one and all, you are watching this video, and even follow this further videos. And already mentioned that Friday, this coming Friday, we have the topic on the remainder theorem, factor theorem and division of polynomials. Okay, Shivam.